Hi, I'm Tim Tyler, and this is a video which discusses the issue of whether the paths of superintelligent machines will be broad or narrow. Enthusiasts for creating general-purpose machine intelligence have often described classical, application-driven development projects as having a narrow scope. Despite, or perhaps because of, the rather derogatory overtones, the name seems to have stuck, and these days general machine intelligence projects are sometimes described as being broad, whilst ones targeted at particular application domains are described as being narrow. Narrow projects have some advantages. They are more likely to pay the bills and actually do something useful in the short term. However, some have questioned whether such development will lead to the type of more general-purpose intelligence found in humans. Here is Ben Goertzel on the topic.
Generally speaking, the question is, can narrow AI incrementally lead to general AI? And this is something that we don't really know the answer to right now. My own intuition is that it's not going to. I don't think that just working on narrow AI applications and incrementally improving them is going to lead to general AI. And I think that's actually a non-trivial lesson that we can draw from the history of the AI field. I don't think it was obvious in the 50s and 60s. Back then, it seemed like doing narrow AI and just gradually broadening the scope could lead to a human and something better. And I think what we've learned now is that narrow problems are susceptible to very clever, tricky computer science approaches, which don't necessarily help you very much at approaching the problem of general AI. And I guess you can use a bunch of analogies for that. I mean, one that's occurred to me is locomotion. Like, the problem of moving on flat surfaces is solved quite well by wheels. But generalizing the wheel may not be the best solution to moving around on general surfaces. And I think the same kind of principle holds over and over. Once you narrow the scope, you can use a trick. And we in the AI field have become very, very good at making up clever tricks. And it's fun. You can think about something for months or years and get a solution that does something really cool. It's kind of seductive because it's easier than making a thinking machine, and you can have the satisfaction of feeling smart and making something that works and achieving something quickly. On the other hand, I have a suspicion that it's not the right path toward making a thinking machine. I think you can transfer some insight from narrow AI to AGI, but it requires a lot of creativity to transfer that insight. It's not direct or obvious. And I think there are some key aspects of AGI that don't really arise in narrow AI whatsoever.
My take on this issue is that the first superintelligent machines will probably arise out of a large organisation with a specific mission. The most likely candidates are probably search engines, stock market investment firms, and governmental security services such as the NSA. These types of organisations seem to me to be the most likely ones to have the money, manpower, and motivation to create the first superintelligent machines. In each case, there is a driving problem, which seems best classified as being associated with a narrow problem domain. However, in order to excel at solving these kinds of problems, considerable breadth of intelligence will ultimately be required. Apart from sheer financial oomph, there is another reason to expect these kinds of projects to be promising candidates for the role of the first superintelligent machine. So far, computing machines have made their inroads into the biosphere largely by avoiding competing directly with humans and instead specialising in the areas where the human brain is weak. Consequently, we have machines with enormous memories, high reliability and rapid serial performance which are appalling at parallel pattern recognition tasks. Such machines complement human intelligence rather than competing directly with it. They augment humans rather than attempting to substitute for them, because human labour is pretty cheap and machines can't yet compete directly with us in cognitive areas where we are strong. The search oracles, stock market masters, and surveillance gurus that I envisage waking up first are utterly inhuman entities whose roles could not be played by human beings. The fact that they are not in competition with existing human brains will help them to get off the ground. So, to summarise, narrow machine intelligence projects will be better funded and are more likely to get earlier access to better hardware and will attract a larger research and development budget. Also, they avoid competing directly with the human brain in areas where existing brains are strong, which is a smart move. The tip of a wedge is narrow, as it must be in order to penetrate initially. A wedge with a broad tip is not very useful. Breadth comes later. Enjoy.